In today's note, we're going to be looking at solving linear systems by graphing. So what it means when we're saying solve linear systems, it basically means we are looking for, or we're trying to find the point of intersection. So what we're trying to do is basically a linear system is basically two lines or a set of lines. And by solving it, what we want to do is we want to be able to find where do these two lines meet. And they're going to meet at a specific point called the point of intersection. So first thing we're going to do today is look at doing that graphically. So we want to determine the point of intersection, and then we're going to check our answer. So the first thing we want to do is graph our two lines. We have equation 1, y equals 2x plus 5, and y equals negative 1/2 x minus 5. So the two things we need to remember, this value attached to the x is our slope. This value, the constant, the value on its own, is our y-intercept. So in the other equation, same thing. The value attached to x is our slope. The value that's on its own is the y-intercept. So the first place we want to start is by graphing the y-intercept. So I'm going to start with equation 1. The y-intercept is 5, so that means I should start at 5 and put a point there. Next, I'm going to use my slope, which is 2, and we should remember that any whole number is a fraction over 1. So in reality, that slope, that rise over run, is 2 over 1, and use that to help me fill in my other points. So I'm going to do a positive run of 1, then up 2, to my next point, and continue that pattern. Once I can't go any further, I'm going to go in the other direction for a few points, so to the left and down, to the left and down, and once I have a few decent points, I can connect them using a straight line. And this is going to be my first equation, or my first line. The next thing I need to do now is I need to graph my second line. So my y-intercept is negative 5, so I'm going to start at negative 5. I'm going to use my slope of negative 1 over 2 to find my other points. So negative 1 over 2, I'm going to make one of them negative. I'm going to say that the bottom is negative, so I'm going to go to the left 2, up 1. To the left 2, up 1. Left 2, up 1. And I can continue going on and even go in the opposite direction, so I go down 1 to the right 2. However, I can already see where my lines are going to cross, so I can stop there and I can draw my straight line in. So this was equation 2, but I can already see where they're going to cross, and they're going to cross at this point right here. So this point right here is my point of intersection, and if I look for the actual value of this point, or the coordinates, it is negative 4, negative 3. So I can write that my point of intersection is negative 4, negative 3. Now, if I want to check this, what I need to do is similar to how we've checked an answer before using our equation of a line. I'm going to start off with the equation of the line, y equals 2x plus 5. And what we're going to do is we're going to sub in the point. So we're going to sub in this point, because remember that a point is just an x and a y coordinate. So that means my y becomes negative 3, 2 times x becomes 2 times negative 4, and then plus 5 stays the same. And now all I'm doing is I'm going through and solving for the left side and the right side. So the left side stays the same. Then I have 2 times negative 4, which is negative 8, plus 5. Negative 3 stays the same again. Negative 8 plus 5 is negative 3. because the two numbers are the same, left side equals right side, -3 equals -3, that means it works for equation 1. However, we can't just end there. We need to do it again, but with the second equation. So the y equals -1 over 2x minus 5. The reason we need to check for both equations is because that point should be on both lines if it's a point of intersection. So we need to make sure this works for both equations. So -3 equals -1 over 2 times -4 minus 5. So all I've done is the exact same thing, plug that point, the x and the y value in for y or x and y in my equation. -3 equals -2, or sorry, +2 minus 5. -3 equals -3. So when I solve each side, I get -3 equals -3, and it does work. So this means that this point is the correct point of intersection. For B, or our next example, we're doing the exact same thing. We're taking our point, or our equations, graphing them, and seeing where do they cross. Again, we want to remember that we have our slope. In this case, because I can't see the number, it's actually 1, and because it's a whole number, it's over 1 as well. My y-intercept is at the end, and the same thing in my other equation. So I'm going to graph each line. Equation 1, we start at -6 for the y-intercept, and then we use our slope of 1 over 1 to plot the rest of the points. And it continues on in both directions. Again, I can continue on till it's full, or I can do a couple where I get comfortable enough that I can use a ruler to draw in the rest. And there is my first equation. I'm going to go through and do the exact same thing with the second equation. Start again at the y-intercept and use the slope of -3 over 4 to plot the rest of the points. So again, because the negative is not on either one, I get to pick where it goes. I'm going to say that it goes on the top because I know that I want to focus on the part that goes down. So I'm going to go down 3, so 1, 2, 3, over 4, 1, 2, 3, 4. So right off the bat, off the first point, I can see already where it's going to cross. So if I'm comfortable enough, I can use my ruler. To connect those 2 points, and I have my second equation. Realistically, we're only concerned about where it crosses, which happens to be right at this point here in black. And the value of that point, or the coordinates, would be 4, -2. So that means that our point of intersection is 4, -2. So to double check to make sure that this point is correct, I need to take my 2 equations, y equals -1x minus 6 for the first one, and plug in the point 4, -2. Again, remembering that the point is just the value of x and y, so I can replace x and y with those values. So y becomes -2, which equals 1 times, instead of x, 4 minus 6. So -2 equals -4 . Sorry, not -1, +1. So 4 minus 6, -2 equals -2, which is correct. So because the left side equals right side, that means that it works for equation 1. For equation 2, I'm going to do the exact same thing. Y equals -3 over 4x plus 1. I'm going to substitute in my point of intersection. So -2 instead of y, 4, and then instead of x, I'm going to have 4. So negative 2 stays the same. Negative 3 divided by 4 times 4. Thinking back to solving equations, those two just cancel each other out. And I have negative 3 plus 1. Negative 2 equals negative 2 when I simplify. So the left side does equal the right side. Negative 2 does equal negative 2. So that is correct. So that means that point of intersection works for both equations, so it is correct. For C, C is going to be a little different, right? I am given two equations of a line, however, they're not in y equals mx plus b form or slope-intercept form, so I can't graph these right away because I don't have the proper information. The pieces are there, I just need to put it into the right form. So the first thing I need to do is I need to rewrite each equation in the form y equals mx plus b. So we've done examples like this in the past, in our past unit. So 2x minus 3y equals 9. I need to get y by itself. I'm going to move the separate term first. It's going to cancel out on the one side. I'm left with minus 3y equals 9 minus 2x. I can't combine those two, the 9 and the 2x, because they're not like terms. One has an x, one doesn't, so I just leave them separate. To get y by itself, because it's negative 3 times y, I need to divide by negative 3, and I need to do the same thing to everything else on the other side. The negative 3 will cancel out. Y equals 9 divided by negative 3 is negative 3. And then negative 2 over negative 3. I'm not going to worry about reducing the fraction, but I will change the signs to positive 2 over 3x. So that is now my equation in the y equals mx plus b form. And from this, we should be able to recognize our slope and our y-intercept. So I can go and jump ahead and graph this one right away. So I'm going to start at the y-intercept. Even though it's in a different location, it's still the value that's not attached to the x. So I'm going to start at minus 3 or negative 3 and use my slope of 2 over 3 to plot the rest of the points. So go over 3, up 2, to the right 3, up 2, and continue that pattern. And I can go in the other direction, to the left 3, down 2, continue that pattern until I'm comfortable enough to use a ruler. To connect all my points. So that is equation 1. Now, before I can graph equation 2, I need to do the same thing, rearrange it. So I have x plus 3y equals 18. I want to get rid of the x, so I'm going to minus x from both sides. One side cancels out, so I'm left with 3y equals 18 minus x. Because it's 3 times y, I need to divide by 3 to cancel it out. So divide everything else on the other side by 3. One side cancels out. Y equals 18 divided by 3, which is 6, minus, there is an invisible 1 there, so 1 over 3x. And this is my equation of the line. Again, I should be able to recognize that the separate term is my y-intercept, and the term that's attached to the x is my slope, which I can use to graph. So I'm going to use that to graph. I'm going to start at my y-intercept of 6, and because my slope is negative 1 over 3, I'm going to go down 3 into the right 1. So 1, 2, 3, 1. 1, 2, 3, 1. No, that doesn't quite make sense. Oh, I read that wrong. So I had my slope switched around. It should actually be to the right 3, down 1. To the right 3, down 1. To the right 3, down 1. So I can see where it crosses. Again, I made the mistake of switching up my slope. Remember, it is rise over run. So that we did have a run of 3 and a rise of -1. So there is my equation 2 line. And I can see where they intersect already. They do cross at this point here. And the coordinates of that point are 9, 3. So my point of intersection is 9, 3. I'm going to go through and check my answers just to confirm. So again, what we're doing is we're taking those two equations that we started with and plugging in the point or the point of intersection and checking if our left side equals our right side. It doesn't matter if I use this equation down here, we convert it to, or we use this original one up here. Either one should be fine. I'm going to use the original one just for personal preference. So we have 2x minus 3y equals 9. Just for reference down here, the point of intersection was 9, 3, I believe. Yep. 9, 3. So I'm going to take these two values, again remembering that a point is just an x coordinate and a y coordinate, and plugging them into the equation. So 2 times 9 minus 3 times 3 equals 9. 2 times 9 is 18. Minus 3 times 3, which is 9, should equal 9. 18 minus 9 is 9, which does equal 9. So left side does equal right side. So it works for equation 1. We need to check the same thing for equation 2. So I'm just going to refer back up to what the equation is. X plus 3y equals 18. Again, I'm going to take the x and y and substitute them in. So 9 instead of x plus 3 times 3 for the y equals 18. 9 plus 9 equals 18. And 9 plus 9 is indeed 18, so this does work. So left side does equal the right side. So this point of intersection is correct for these two lines. So the key thing again for this note is if I'm solving a linear system, I want to find the point of intersection. And by doing that graphically, I just have to graph my two lines and see where do they cross. I can check to see if it's the right answer by taking the point and substituting it back into the equation and checking if my left side does equal my right side.